We're going to get into one of the more exciting topics in malware analysis, and that's actually taking a look at the code. And this is just something that you get better with over time. It's one of those skills. I can teach you the fundamentals, but just like you saw with pen test, this is one of those things you just have to do over and over and over again. And the more you do, the better you get at it, because we're dealing with code that has been written to be difficult to understand. It was purposely designed to be obfuscate. First off, can everybody hear me? Am I talking to myself again? Perfect. Thank you, Juan. Thank you, Bernard. One of those things that you just have to do over and over again, and the more you do it, the better you become at it. It was one of the requirements from the advisory group that you understand how to use these tools. It was important that you were able to set up these tools, but also be able to understand how to use these tools. And this tool is big. The tool we're going to look at today is big and complicated. And I've already heard from one student who graduated from the group before you. When she ended up in industry, she was actually expected to be able to use these tools. Of course, there was a training period, but this became her job. She became somebody who had to go into malware, disassemble it, understand what's going on. So the first time I taught it was in a bit of a vacuum. This time I can tell you that at least one of the grads who came before you are using these kinds of tools. As always, when I teach these courses, I focus on keeping you using open source tool sets. When you get into industry, you may be using open source tool sets. The open source tool sets are phenomenal. They do a great job, but you may also be using some proprietary tool sets as well. We set up IDA free in a previous class. A lot of what you do in this, you can also do in that tool as well. And there's a professional version that costs a lot of money. So it's more important to understand the techniques rather than memorizing the steps, because especially in this one, memorizing steps isn't going to help you. The technique, the way of stepping through code, looking for information, discovering something, and then pivoting on that discovery. Sounds familiar, doesn't it? Very similar to the kinds of activities we did when we were doing pen testing. All right, so let's begin. Today's lecture is in a PowerPoint presentation because there's a lot happening and there's a lot of concepts to support it. So let us begin. Disassembling is basically converting compiled code into something more human readable assembly language code. And that's a big, I actually dislike air quotes, but if you could see me, if I was actually standing in front of you in a classroom, I would make air quotes, because human readable is a bit of a stretch. It does convert compiled binary code into something that we can more easily understand. But if you want it to even be more understandable, get to some of the commercial ones that translate the compiled code through assembly right back into something like C++. So it is even more easy to understand, where they create functions you can step through the code a lot more easily. We will be decompiling this. We will be able to understand what's going on, but we're not going to go the full length, all right? Static code analysis basically involves a disassembler to examine the code without executing it, as we've seen in the past when we've done other types of static analysis. Dynamic code, however, what we're going to be doing today, when we're getting into code level analysis at the dynamic level, we're going to have to execute the code again, which means that we have to run the code. What's different this time is that we're doing it inside of the disassembler, so we can step through the code and understand what's happening at key points. You can step through line by line by line. I don't advise it. It is long and tedious. What's better is to understand what you want to get from it and step through in that manner. Okay? The tool that we're going to use, X64 Debug, can do both static and dynamic analysis, but we're going to do the dynamic analysis today. Okay? X64 Debug is a debugging program with a built-in disassembler. It's open source. You can actually download it from GitHub, but it is included in Flare VM. There's two different versions, a 64-bit and a 32-bit. There's also an X96. I haven't seen that, but we're going to focus on X64 Debug. But there is also an X32 Debug as well, and apparently an X96, but like I said, I've never seen that one. It doesn't work. Rather than, as I said, stepping through line by line by line in your executable code, it's easier to set breakpoints, points where you can actually stop the execution of the code. And okay, sorry. So, you know what? If I'm repeating myself, I'm sorry. I'm going to repeat myself. X64 is the debugger that we are going to use. It is a debugger, but we see it used an awful lot in malware analysis. It does allow for plugins. One of the plugins we're going to talk about today, but we're not going to use it. It is included with Flare VM. You can find it in GitHub. There's also an X32 debug, which you can look at 32-bit code, and there's also X96, which I've never seen before, which will look at 32 or 64-bit code. And as I said earlier, you can step through the code one line at a time, but it is long and tedious, and it's like looking at log files. You're going to get lost in the noise. What's better to do is to actually set up breakpoints, to set key points that you want to stop the execution, okay? It's handy to know where, right? For example, we know there was a brbbot file that was created. We think we know that that may have been uploaded in our last analysis to our web server, but we don't know what's inside of it. So we want to try and figure out what that is. We believe it's encrypted, so we're going to have to try and find that encrypted key inside of the code. So that's what we're going to try today. And the only way to do that is to step through the execution, try and find the APIs that it uses for those things, and try and get some of the arguments that those APIs use. Okay? Another way of doing this is a tool called API Monitor. It has a library of API calls. Sometimes it works, sometimes it doesn't. So, what is an API? An API is an application programming interface which allows certain functions to accept arguments. They're built-in functions. A lot of apps use APIs, standard APIs from Microsoft. And when we're going through, we should probably be researching these APIs on the Microsoft website. So that means in our configuration, when we're looking at these things, we need to have both Flare running and Remnux running because, there we go. All right. So we're going to have both Remnux and our Flare because, of course, our Flare does not have internet connectivity. So if we're going to be researching our APIs, we're going to need to do that through a web-enabled browser. You can, of course, also use the browser built into your host VM here. There's nothing stopping you from running Firefox inside the malware machine. Like I'm just minimizing these right now. I have the host environment running, and of course I have internet connectivity, so I can also research the APIs in the host environment as well. I don't care where you do it. I really don't. So as long as you can have your ability to research these APIs when you have your Flare VM, which doesn't have connectivity running. Okay. I am recording the desktop Mamta. If you want to record inside of Teams, go ahead. I hadn't started that, but if you wanted to start a Teams recording, go ahead. The function will be sent in assembly code, and then you will use the API library to understand what those calls mean and what keys are going to be used with it. For example, take a look at the read file call. It's going to have 5 arguments. Yeah, no problem, Amta. It's going to have 5 arguments. The first one is going to be the handle, and then it's going to return often these things as well. And it's handy to take a look at the website. Well, you know what? Let's do that now. Let's go into our browser, and we're going to Google read file API. Let's say API, read file API. And typically the first response that you get when you search these things should be the docs.microsoft.com. It's the old, what did they used to call it? They used to call it something else back in the day. What was it called? I know I have it in my notes here. Oh, the old MSDN, that's what it was. It used to be the old MSDN website, but now they're calling it Microsoft Docs for whatever reason. But again, you could take a look at these functions and see what's going on. It should also tell you what gets returned. If the function succeeds, it'll return a non-zero or true value, but it'll give you an indication of what these different API calls mean, what they expect, what each of these are going to be. So it allows us to better understand what might be happening. There's also the Crypt Decrypt API call, Encrypt Decrypt API, okay? Crypt Decrypt function. That's the one we're looking for. The Crypt Decrypt function also has certain things, including what key is going to be used. Okay, so again, at certain points, we're going to want to understand how these different APIs work and how they are used in the code that we are looking at. Okay, so the Microsoft.com website, specifically docs.microsoft.com, where it explains all the different APIs you are likely to see, is a great resource to have going when you are doing these kinds of attacks. There it is, the Crypt Decrypt function. There's also an encrypt function as well. You can research that as well. Okay. One of the handles that is used in this function is the key that is used for the encryption and decryption process. It's probably the first one. So we need to keep that in mind when we're looking at the different handles that these different functions use. That's the key. And we saw in our last analysis something that looked like it might have been encrypted. If we can understand how it was encrypted and more ideally what key was used, we may be able to decrypt that string and understand exactly what's going on during this attack. Any questions? Okay, so what we're going to do now is we're going to launch our X64 Debug. When you first launch it, there's a couple of different things going on. There's a bunch of tools just below the menu. A lot of these tools are ones that we can use. There are also menu items that give you the same functionality, and for many of these tools there are also function keys. Until you get comfortable with the system, I would suggest using the menu items so that you don't select the wrong one. There's also a number of tabs, as you can see in this graphic, for different kinds of things that you might see. One of the tabs that might be available is a tab called Snowman that, again, might allow us to decompile this from assembly further back to C++. In previous versions, we could see that. For whatever reason, the assembly code decompiler was not available in this version. And I took a look at it, and you could actually download it and add it to this, but it's out of scope for this because we don't actually use the Snowman add-on to the X64 Debug, so we're not going to worry too much about it. But it is something that is available. If you want to take this code and go from assembly back to even more easy to read C++, get the Snowman working, and then you'll be able to do that more easily. All right? So that's at the top of the application window. At the bottom of the application window, there's a little status bar that tells you what's going on. And it's either going to be running, it's going to be paused, and typically that's what's going to happen because you're not going to get running unless you forget to set up breakpoints and just leave it running and running and running, which you don't want to do because then you have your virus in a runaway mode on your system. Ideally, you've got breakpoints set up and you're stepping through those one after another. So that's what this ready line is. And it'll also have information next to it to what it's analyzing. Once we load our brbbot, that status bar will change to reflect that. There's also a command window. On top of going through the menu and setting certain breakpoints, you can also type in commands as well. And we'll be looking at that today. Okay? And this is what it looks like when it's actually loaded code. Again, not easy to read. Much easier to read than binary, but it's still assembly language and still difficult to read. But it will show us API calls, and those API calls, we can take a look at the results. There's different parts in this application that we will be taking a look at. For example, this area here is the disassembly plane. You can see the graphic over here. We've actually got the register plane or the results of the different handles that we might see. There's a memory dump area. I don't think we make much use of this. And then there's a bunch of variables here that we can take a look at, the stack. Okay, there's a couple of other tabs as well. We're going to, oh wait, but before we do anything, when we first load it, we don't want our code to run. So one of the things we need to do is ensure that when we start up that we've got an initial breakpoint. So as soon as we load this executable into the X64 debugger, it stops, it doesn't stop, it pauses execution at that point and allows us to go through and set the next point that we want to see this at. Okay, there's a graph tab that allows us to take a look at a graphical representation. There's a breakpoint tab which lists out the breakpoints that you've defined. We're going to define a bunch of breakpoints ourselves. And as I said, you can actually start the process and step through line after line after line. It can be tedious and you can miss stuff. For any of you who've actually worked in a data center, you know how it's sometimes challenging that can, not a data center, but a network operations center. You know how tedious it can sometimes be trying to look at log files all day long. This would be about as tedious as that. Are there any questions? Any questions? Okay, so let's take a look at this. So now I'm back in my Azure server. I've got Remnux running. That's handy. I also have Firefox running. I don't really need that here. I have my Flare VM running. So I've got Remnux running and I've got Flare VM running together. You probably want to both running, although I don't know that we're going to be actually using Remnux today. Actually, yes, we will, because we're going to, once we discover the key used for the encryption, we're going to run it through. So in Remnux, ensure that you've actually got your captured encoded.hex file that we did last week. If you haven't done that, then you have nothing to decode once you find the keys. So from our last class, we had encoded.txt. Make sure that you still have that available to you because we're going to try and decode that information. But we're not there yet. So one of the first things we want to do is launch X64 Debug. All right. Once you click yes, it'll bring up the X64 utility. You also want to ensure that you've got I'm pretty sure we also have to start I'm pretty sure we have to start process hacker. I'm going to start process hacker as well. Doesn't matter which one. Yeah, I'm pretty sure we're going to want process hacker running as well in case we want to stop our execution of our malware as well. It doesn't hurt to have this running in the background, but you can see X64 Debug running in the Explorer area, which is fine. Yeah, I'm pretty sure we're going to want that running as well. Okay, now I'm going to be jumping back to my notes quite a bit to make sure I don't miss anything. Okay, and also please note that I didn't restart my environment. There's value, as I said in the past, in restarting your environment based on ensuring that you have an actual clean environment, because a lot of these malwares, they'll do their damage and then they'll change the way they execute. They're polymorphing malware. They change once you execute them. So in the real world, I would step back everything that I did before, go back to a nice clean setup of my Flare VM. I would, if I haven't already done so, re-download the malware, reconfigure it for the proper environment, and then detonate it inside of the debugger and step through the code. This virus is not that complicated, so we're okay. I think I can drag and drop. So no, file, open, and I want to open up the executable. So you could try opening it up here, but I wouldn't because it's not, again, it's not in the spot. So I'm going to, let's take a look if I can open up the shortcut. Yeah, I can open up the shortcut off the desktop. That's fine. But what's important is what you see right here. Now, you can, on your side, when you're watching these presentations, you can hold the control button on your keyboard and use the mouse wheel to zoom in. I can't make this any bigger, but right down here in the lower right corner, correction, the lower left corner of my X64 Debug, it shows the status. It says system breakpoint has been reached and it's paused. And the reason is options, preferences, settings, yeah. Because we have the entry breakpoint setting set already in place. We don't need to change these settings. They should be fine. But because of that setting, when we first loaded it, it was paused. And that's exactly what we want. So we've loaded this into our environment, and because we've done that, the brbbot.exe is now a sub-process of the X64 debugger. Now keep in mind that Process Hacker is outside of this environment. So you must understand, again, your environment. We are running this virus. It's paused. You can see nothing's happening. There's no I/O. There's no memory change or anything. It's a little bit of CPU change. I think that's just because X64 bug is changing and it's assuming a certain percentage of it. I'm not sure. But at the end of the day, brbbot is running in this environment. It is a dynamic analysis. Any questions on that? Now, as I said, you can click and step the next one. Step, step, step. You can click run and it'll just start running, but you don't ever want to do that. But a lot of the options that we're looking at can be done in the debug. Run until selection, pause it, restart everything, step, 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 step. And we're not going to do that. We're actually going to take a look at setting up some other things as well. What we want to do is we want to set a breakpoint, because when we were looking at PE Studio and some of the other static analysis, it showed us that there was a read file call. And with the read file call, it also told us, or we saw that there was a file called brbbot.exe. So why don't we try stepping up to that point and see what happens? Rather than going through everything else, one of the easiest ways to set, and by the way, for those of you who are following, I am on slide 21 of the handout. What we want to do is to set PBX. And as you type, set BPX, sorry. As you type, it has a context sensitive, and you could select it. Set BPX. And what you want to do is you want to set it to the specific API call that you are curious about. And the one we are curious about is read file. So again, what did I do? Let's try this. Oh no, let's just do this. Set breakpoints, read file. That's what I typed in the command area inside of X64 Debug. This command doesn't really matter, all right? It's going to be context sensitive. It'll figure out what you're trying to do. As you type it, it'll suggest stuff and you can select it. The read file, however, is going to be case sensitive. So when you're typing read file, make sure you match the case. Uppercase R, uppercase F. If you don't match the case, good chance, very good chance that you are not going to set the breakpoint at the right spot. Okay, so this is what we type in as our command. When we do that and hit enter, breakpoint was set at a specific memory location. And that's going to be different for everyone because it's going to have different things loaded in memory. Okay, so because it has different things loaded in memory, there's going to be different memory locations that have the point where we want to stop our execution. We've talked about that. Once we get to that breakpoint, we take a look at what's going on around that breakpoint spot. Okay? So now that we've set a breakpoint, there's a breakpoints tab here. We can actually see that our breakpoints are here. We have our entry breakpoint and we've got our read file breakpoint. And that's where we're going to jump to, or we're going to step to next. I clicked on the breakpoints tab. Now that I'm away from it, I can go back to the CPU tab. As I mentioned, there's a number of tabs here. Yeah, that doesn't help me. One of them used to be the snowman, and it's not there anymore, but that doesn't matter. Also, we see down here that we're still paused and we're ready to go. Okay. At this point, though, we can go debug and run, and it'll run to that breakpoint because we have a breakpoint set. If it doesn't stop, then we haven't set our breakpoint properly. But we're pretty confident because our breakpoints are listed right here. So I'm going to go back to the CPU and I'm going to go debug and run. I could hit F9, I could hit the little arrow, but until I'm comfortable, I'm going to use the menu so that I understand exactly what's going on. At that point, my status bar is then paused again. It's at breakpoint entry breakpoint. Let's try that again. Debug and run. And so I had to do it a couple of times. And that's fine. Okay, so it hit the entry breakpoint again. That's fine. And now I've hit the read file breakpoint. Perfect. And I'm paused again. Perfect. And I can see I have the read file. I have the read file all around here. Okay. As I say on page 23 of the handout, you might have to hit it a couple of times because you need to get past that entry point breakpoint. Okay. We know that there are 5 parameters, all right, and we can see those parameters. Let's see if I can make this a little bit bigger. We can see those parameters right here. These are the different parameters for the read file API call, okay? You may have different parameters, but you're going to have the same 5 parameters. You just need to understand what those mean. Mine's F0. Yours might be EC. Mine is F0, so I have to understand what those mean. Okay? It's funny. Some people actually get the exact same values. I get different values, but that's okay. Okay? So, where I go to my handles tab, we take along the top here. Right near the end, we have the Handles tab, keeping in mind that my handle is F0. So I go to the Handles tab. I have to refresh. Where's the Refresh Handles tab? Refresh. There we go. And my handle was, let's go back here to my CPU. It's F0, right? My handle is F0. So I'm going to go back to my handles. See if I can find the F0 handle. And there it is. It's pulling in brbbot.exe. So we're on the right path. Okay? Again, your handle will be different depending on your code. Let me refresh this. When I step through and first off I created a breakpoint for the read file API. When I stopped at the read file API, I took a look at the different results that not the results, but the different parameters, the different handles that the read file expects. The first one is the one I am interested in. The first one had a handle value of F0. Perfect. I'm going to the Handles tab. I had to refresh because it didn't have these when it first started. Now that it's got something, I can take a look at it. And when I take a look at the handle F0, it tells me what the value is. And the handle it is trying to read is brbbconfig.temp, which makes sense. That's what we thought it was going to be. Okay? Any questions? All right. We should also see this in Process Hacker. Now that it has stepped through and done some stuff, we can right-click and take a look at the properties of brbbot.exe. One of the tabs in this is Handles. And it's not letting me do it. Okay, so sometimes it works, sometimes it doesn't. It has worked in the past, though. Maybe I needed to run this as... interesting. Access denied. So maybe I should have run Process Hacker as administrator. But you would also be able to see the handles here as well. And you would also see the handle number and exactly what the value of that is. And you would have been able to confirm your results here. You should be able to do that. I'm going to try Process Hacker. Instead of Process Hacker 2, I'm going to go find my brbbot again. Right click, Properties, there it is. So there we go. That's the difference between Process Hacker and Process Hacker 2. If you're running Process Hacker 2, close it down. We're just going to run Process Hacker. Not Process Hacker 2, but Process Hacker without a space. Process Hacker allows us to find our executable, right-click, select the properties, and then go to the Handles tab. And in the Handles tab, you should be able to find, you might need to make it a little bit bigger, the handle 0xF0, and with that handle, the value that is in that handle. Again, it's showing us the same information, but that's why we do it. We want to make sure that the information we are seeing makes sense. Any questions on that? Does that make sense? Okay, so again, we can step through our code. We can try and find the next thing we want. Again, I'm in the Handles area. I need to go back to the CPU tab because I'm going to get it to start running again. We can step through and look for another breakpoint, read file scatter. Don't know what that is, but I might want to research that and see what's going on. But at the end of the day, they read in a file and then they did something with it. Okay, we know that they read in the brb-config.temp file. What did they do with that information? One of the things you can try at that point is to then continue to run to the user code. Again, under the debug menu, you can select run to user code, and that'll take you to the next thing that the user did that wasn't part of the Microsoft API call lab. And then we want to inspect what's going on around it. There's our read file. There's there it is. There's our read file, so that could be very well the function we were just looking at. There's a test statement, then there's some extra stuff here. And then we get down to another API call, Crypt Decrypt. And that's the one we are looking at. That is the one that we see. All right? Because we thought there was some encryption in that file, I definitely want to take a look at what's going on with that. Okay? When we take a look at the Crypt Decrypt function, we see that the first handle that gets returned is the key. If we are correct in our assumption, we can take that key and use it to decrypt the text that we discovered in our network analysis in our last class. Let's take a look at that. Okay? What I'm going to do is I'm going to select this, and then I'm going to tell it to run to that point. Or, better, select the line below it and take a look at what is going on. We can select this and then we can step to the next point. But when I learned how to do this, I select the line below it because it'll already have done that API call. We can go to that point, we can step to it and then step through it one after another. But it's actually a little easier to go one step beyond and let it do its encryption call and then take a look at the stack, take a look at the memory, take a look at all the different tools that we have available to us and see what the values are. So I'm going to select the line below the Crypt Decrypt function, and then I'm going to debug run to selection, run until selection, or F4. Again, it steps through. Again, it's paused, and it's paused on that point that I selected. But a lot has happened. We see some values here. Because it is finished executing my Crypt Decrypt function, we see some results here. We also see some results here. Specifically something called encode 5B. All right? That's very telling. That might actually be the key that we need. We also have some other stuff here as well. Recall we had the ads.php in our previous one, and now we're starting to see some of the parameters that are passed. Exec equals cexe, what we call sexy. File, which is equal to elif, end file. Conf, or configuration, is equal to fnoc. All right. So again, these parameters are the reversed. Exit is equal to tixi. So that's kind of the language we use around these. Sexy, elif, fnoc, and tixi. But encode is equal to 5B, and then sleep is equal to 30,000, or 30 seconds. Now you know why I've been asking you to wait 30 seconds every time we executed that malware. All right, it's a good number, but it actually had a purpose this time. We see the results down here as well. All right. Any questions? If we take a look at the register pane here, we see that RAX, which is the 64-bit, if we were doing 32-bit, it would have been EAX, but we're in RAX mode. We have a return value of 1, which is a non-zero return, which means that it probably correctly either encrypted and or decrypted our text. We are looking at the encrypt, decrypt. So we're talking about a decrypt, a successful decrypt, and we've got some values in this register pane here, telling me that it successfully decrypted the information. And we could take a look at the results. And on slide 34 of the handout, there's many different ways of seeing this information. You can look at it up here in the registry. You can look at it here down in, I can't remember what this term is, drawing a blank, sorry, but you can look at the different parts. But at the end of the day, this is what we're looking at. We get these results as seen right here. Okay. Now that we have this information, we can start understanding what's going on. And we'll see this in our next class, when we actually start trying to crawl a website and emulating these activities. Okay? The main things we're looking for is this encode is equal to 5B. And I think everybody's going to get the same results, but if not, we can deal with it at a later date, but there should be some kind of an encode string there that we can maybe use and an indication of how often it happens, this being probably 30 seconds. Now, again, this is the first time we're doing this, so I selected a bit of malware that has very easy to understand. We're going to call these command and control arguments, because that's what's going on here. This is a command and control server that this application, this malware, is trying to call, and it's expecting results back. Okay? It's going to respond on what it gets back as it sends out these requests. They're GET requests, so it'll just throw it out and it'll get something back right away. Normally, the parameters are not so clear. Normally, if you had an encode string, the parameter wouldn't be in code. sleep wouldn't be sleep. It would be a little bit more obfuscated than that. We'd have to do a little bit more research, but as our first look at this, they make very good examples. Okay? Again, we have a 5B as a string, and we have 3000 as a sleep value, so it's going to the command and control server every 30 seconds. All right? Now we've got something that we can use to try and decode the text that we saw earlier. So again, we're going to go to our remnux, we're going to navigate into our directory, and we're going to try and decode this text. Before we do that, we really need to convert it back to a raw binary format. It has been converted into something other than raw format, and we need to revert it back. And we do that with the XXD utility. XXD can convert raw into a little bit easier to read raw memory information, raw dumps of data. We need to convert it back. All right. We do it with the command that you can find on page 43 of your handout. XXD-R, I think, to reverse, -P to, I can't remember P, I think it's to output the results to the screen, and have my file here, encoded.hex, and I want to redirect the results to encoded.raw. I'm trying to create the raw binary that we have before so I can try and unencrypt it. If I try and unencrypt this fixed, cleaned up version that I captured from Wireshark, it's probably not going to work well for me. So I need to convert it back to a raw file. And once I've done that, then maybe I can take a look at it by unencrypting it. And we do that with the translate.py command. Encoded.raw, decode.txt. I'm converting encoded.raw into some block of decoded.text. And it wants an argument byte caret 0x5b. That is the key that we're using, so we're telling it to use that to try and decode this text. If everything works properly, I should now have a file called decoded.txt. When I take a look at that, no. Oh, you guys are using Vi. No, never mind. I'm going to use Vi because you're learning Vi from Brad's classes. So now I've got a file called decoded.txt, decoded.txt, and there is my decoded string. And I'm asking you, what does that look like? Anybody? You can also see it on page 44, but that text editor is no longer available to us, unfortunately. First off, what you see might be different than what you in yours than what I see in mine. Okay? That is a list of executables. Why would they do that? If they know what's running on your computer, they may be able to do other things. By getting an idea of what's running and understanding what vulnerabilities might be associated with that, they can, with their command and control system, execute other things. They can have you load other tools running. We see things like brbbot running, service host running. Many times is service host running. Many, many times. And as a matter of fact, this list of executables is probably going to closely match what was going on inside of Process Hacker with all of those different child processes running. But getting a list of executables then allows your attacker to take a look at those and maybe exploit some of them. Okay, and that's probably why they've done that. Also, given that it's command and control, we may be able to get it to run other commands as well. Now that we know that some of the stuff that is running, we may be able to get it to run other commands as well, and that's what we're going to do in our next class. Any questions? I know this is anticlimactical when you just look at it. You're hoping to find some great, interesting stuff, but at the end of the day, the attacker we're still in the initial stages of understanding what's going on. The attacker is getting a list of executables so that they can start using some of these to get a better access, not into your system. Keep in mind what happens when everybody's running the same operating system in the same environment using often the same architecture. I mean, you've all got different laptops that you're running, but you go into industry and you see an office, everybody's going to be using HP, or everybody's going to be using Dell, or everybody's going to be using, the standard same equipment, because sysadmins don't want to have to manage 20 different architectures. They want one or two, and that's it. If they can get everybody using the same thing, their jobs are easier. If one hacker can get a list of executables running on one of those machines and compromise them, they can spread that to other machines in the environment. And that's pretty much what they're trying to do. Okay? This is an example of exfiltrated data. They're just trying to get information out of your environment so that they can try and move it to the next stage. This is still in the intel gathering phase of the attack. Are there any questions? Does that make sense? Now that you've successfully captured this information, you can stop this from running. There's a couple of different ways of doing it. Simply by closing down the X64 debugger, we can then see that, I don't need that, we lose the process inside of our process hacker. By closing down X64 debugger, we close down all the child processes, so we stopped our malware from running. brbbot is no longer running in process hacker. We can close this down, and as always, we can elegantly shut down all of our environments. Okay. Envi::q to quit, as I'm sure you know this. Exit. Because I've captured my text, I'm good, and I can shut down my Remnux. And then I can, as always, shut down my Azure client.